So it is all about the requirement of the good aggregate. Next is properties of fine aggregate. The size, first one size. The size of the fine aggregate should be less than 4.75 mm. Using larger size aggregate will give a more dense concrete, but mixture of all size aggregate having the greater strength and more economical. For the properties, first point is the size. If we use the aggregate of larger size, will give the more dense and greater strength concrete. But mixture of all aggregate is most suitable for the economical purpose and also the durability. So the aggregate size for the fine aggregate should be less than 4.75 mm. This is the first property of the fine aggregate. Shape. Sand of irregular shape is preferable to completely round granular shape of the aggregate, because the irregular aggregate are having the greater bonding strength. So rather than rounded shape aggregate, we can use the irregular shape aggregate for the construction work. Next one, specific gravity. It is the ratio of density of aggregate to the density of water. So specific gravity of aggregate is required to determine, because where we require to we calculate the weight of the structure or the dead load, etc. Next one, bulk density. It is the ratio of weight of aggregate to the its volume, that is aggregate with voids. We take the weight of the aggregate including voids and divided by the volume, then it will give the bulk density. So it is necessary for the batching of the aggregate, that is converting the aggregate from the weight batching to the volume batching. We require the volume of the aggregate. Next one, moisture content, that is water absorption. So it is the ratio of the, or it is the quantity of the water which is absorbed by the aggregate. So the quantity of the water absorbed by the aggregate should be less, because if it absorbs the more quantity of the water from the concrete mix, then it will affect on the water cement ratio, and it definitely affect on the strength of the concrete. So to avoid this drawbacks or the adverse effect on the concrete, we require the aggregate with a less percentage of the water absorption or having the less water absorption. So minimum, that is the we allotted, that is the 5% for the aggregate, fine aggregate or the coarse aggregate. Generally, aggregate are available from the or natural source, which are aggregate are taken from the natural source, are having the very low water absorption, or during the construction work we can sprinkle some water onto the aggregate so that they will absorb the water before the mixing, and then we add into the mixer or during the mix with the concrete. So water absorption is mostly considered in case of the brickwork, because bricks are absorb the more water as compared to the sand or the aggregate. Next one, bulking. Bulking of sand means increasing the volume of a sand due to the surface moisture. In case of the moisture content, the sand bulks or it increases its volume due to the presence of moisture. So some up to some limit, presence of moisture will increases the volume of a sand, and after saturation again the sand comes to the original volume. So bulking effect is required to be considered during the volume batching, because if there is any rainy seasons or the due to the any due to the water, if there is a change in volume of a sand, then it should be considered during the volume batching work, and we have to be apply some correction to the bulking of a sand during the mixing. Surface texture. So surface texture is the property which defines the surface of the aggregate, that is the rough or the smooth. So for the proper bonding of the aggregate with the cement, we use the rough surface aggregate because they are having the proper bonding with the aggregate, with the cement and other ingredients of the concrete. So the rough texture aggregate are most suitable. That is like the crushed stone pieces. They are having the greater bonding property than the aggregate with the smooth surface. Soundness is the ability of the aggregate to change its volume due to the change of physical conditions like the temperature or impact, etc. So if we use the aggregate with a greater soundness, so then it will changes its volume due to the temperature, or it will expand and contract due to the variation in temperature. Then it will produces the cracks on a concrete or the structures. So the aggregate with the minimum expansion and contraction are allowed for the construction work. Next is durability. Some of the aggregate contain the various type of the elements of the material or the chemical compositions, and they will affect on the durability of the concrete. Also, the durability of the aggregates are depends upon the weathering conditions, uh, resistance of the aggregate to the weathering conditions and the various chemical attacks. So the aggregate having the greater durability is useful for the construction work, because if the aggregate or ingredients of the concrete are having the greater durability, then our structure will definitely have the maximum durability uh, against the weathering action and the other chemical or the other disintegrating forces. Specific surface. The surface area per unit weight of the material is known as the specific surface. So specific surface area will on uh, affect on the requirement of the water for the mixing of the aggregate. The aggregate having the low specific surface area will require the minimum quantity of the cement paste for the mixing. So the aggregate with a low specific surface area is useful for the construction work. Last is the strength. The strength of the concrete is not only depend on the strength of the aggregate, but strength of the aggregate is most important, because we cannot say the if aggregate is having the greater strength, then concrete will be have a greater strength. But because the concrete is made up with the all the ingredients like the cement, sand, aggregate, and chemicals, etc. When all these ingredients are having the greater strength, then only the concrete will produces with the high strength. Because if the single ingredient like aggregate is having the greater strength and other cement or the coarse aggregate will have the low strength, then concrete will not have the specific strength during the uh, load resisting conditions. So to make the concrete with a greater strength, we require the ingredient with a high strength. So the aggregate with a greater strength will most important for the concrete with a required specific strength. So these are the properties of the fine aggregate. So it is our one of the trial lectures. So thank you for joining with us.